Okay. Here, so we have one more problem in dynamic programming. Reliability design, where it is basically it is in dynamic programming. Dynamic, okay, programming. Okay, na? So this is reliability design. I will tell you. What is this problem statement is nothing but I will tell you. Suppose you wanted to design one online studio, online teaching studio you wanted to implement. Okay, teaching studio. So what are the things is required? Basically, you need devices. Yes or not? Again, for every device, you will going to find the reliability. Reliability is nothing but supposing. So devices are like marker. Okay. Marker may work for a few days. After that, it will become dry. Okay. We don't know exactly how much days it will going to work. That is what we call it as reliability. How many days it will going to work? We don't know exactly. So 90% of the marker, it will work perfectly. 10%, that 10%, what we have to do, we have to check it out. Yes or not? Suppose think like that, one marker is there. Think 70% of the marker will going to work. Okay. So, but 30% of the marker is not going to work. Those 30%, how we will going to increase? That is for this particular device, how we will going to increase the reliability. Again, every marker will going to have a cost, right? That is what exactly I will going to design a one. I will going to design one thing. What is that? I wanted to build a system. Okay, one kind of system, any system. I wanted to build a system. For that system, I will going to apply the algorithm to achieve the maximum. Understanding everyone, to achieve the maximum reliability of each device. Okay, understood everyone? So that is what exactly I'm talking about. Suppose think like that, I will going to take the device D1. Okay, again for that is something like R1, you reliability, you take it as R1. So what happens here? R1 is giving 70%. So another 30% I wanted to achieve. What you will going to do? Additionally, you keep one more marker. Okay, then if this marker is not working, this marker will going to work. So hence both the things combined together, you will going to achieve 100%. That is what exactly. Okay, so this is the reason why we have to study this reliability design. So for this, we will going to apply the algorithm. Understanding? For this, we will going to apply the algorithm. 1 minute. These things not required. Okay. Now, so that is our problem statement. Understood everyone? That is our problem statement. What is that problem statement is all about? So consider any device. For that particular device, we have to achieve the maximum reliability. So I will going to achieve, suppose I will going to take one device. Again, you have to add one more device for that particular alternative. We will going to add the alternative device for that particular device. So that if that device fails means another device will be there. So that we can able to achieve the maximum reliability. So that is the reason why we have to identify one more important thing. What is that? How many devices you have to keep that to achieve the maximum reliability. Yes or not? That is what, see, one marker is there. So it is giving 70%. If you bring another marker, it will going to give you another 30%. Together, it will going to achieve 100%. We have to understand very clearly how many devices, if we take, we can able to achieve the 100%. Yes or not? Okay, if you take two devices, you will going to achieve 100%. So again, you have to worry about cost also here. Yes or not? Again, you have to worry about the cost also. Think like that. This one is costing us 100 rupees. This one is costing is 150 rupees. Basically, your budget itself 100 rupees. Then what you will do? Basically, this is not a suitable case. Yes or not? That is not a suitable case. So that one we have to achieve here in the reliability design. That is what we are discussing here. Okay, fine. I think you people got this. The idea and problem statement you understood, right? That is our problem statement actually. Fine. Now see here. Consider, consider here. So we have a device, okay. Again, reliability. So device, you take anything like something like D1, D2, and D3. Okay. For every device, we will going to have a reliability. Yes or not? R1, consider like this. R2, again R3. If I want to buy the device, we should give some cost, right? So we have to pay some money and we have to buy it. So that is the reason why cost also is there for this. Okay. Cost is, take it as C1, again C2, again C3. In general, for device, I will going to give the notation that is called it as DI. So DI is nothing but what? Basically, it is a device. That's it. DI is nothing but what? Basically, it is a device. Okay, done. Again, R1 is there. Here, RI is nothing but reliability. R1 is nothing but reliability. RI is nothing but reliability. That's it. Okay, now fine. I think you people got this. So how many devices are there? See here, everybody observe here. How many devices are there? Are varieties of devices are there? Okay, different kind of devices are there. Different devices are there. Okay, different devices. Again, reliability. For every device, we have a different reliability. Correct? For every device, D1 we have a reliability R1, D2 we have a reliability R2, D3 we have a reliability R3. Again, cost also. For R1, see, for D1 we have a different cost C1. Again, D2 we have a different cost C2. Again, D3 we have a different cost, that is C3. Correct? Okay. That is what exactly I'm talking about. Every device have a cost. Every device have some cost. Okay, done. Fine. Okay. Again, here also reliability for every device. Okay, done. I think you people got this. See, very simple. The concept is very simple. I wanted to create one system, something like I wanted to create one system. For that, what are the requirements required? Something like devices are required, yes or not? So how many devices are required to achieve the 100% reliability of 100%? Okay, so what we have to achieve? We have to achieve the 100%, but they will going to say within this cost, some cost they will going to give. Within that cost, we have to achieve that 100%. That is the problem statement actually. Okay, done. Fine. Now see here. Okay, I will going to write one line, please. I will going to write one line here. One line I will write here. What is that? We want to design one, or design a we want to design a system in that system all the devices are connected serially. So this one I will tell you what is this exactly. So that is what exactly I told you. Here, suppose think like that. I wanted to design one system. That is the problem statement here. I wanted to design one system. Something think like that, You people think, assume like this. We have a system like this. Okay, we have a system like this. Okay, we have a system like this. Again, here what they are saying, connected serially. I will going to connect the system. I will going to connect the devices serially like this. D1. Okay, here D2. Again here D3 like this. So from here, I will going to give the input here. Again from D1 to D2. Again D2 to D3. Again output here. So this is input. Again, after crossing all devices D1, D2, D3, you will going to get the output. So this is our system. Okay, this is our system. And here all the devices you can able to see, D1 is there. There is a device D1. There is a device D2. Okay, there is a device D3. All these devices having a reliability R1, R2, again R3. Okay, fine. No, right? Any problem is there? So this is what serially connected. Yeah. D1, D2, D3. These are all serially connected, one after the other. Okay. If you want to get the output means you have to pass the D2. If you want to get the output, you have to pass the D3. Then only you will going to get the output. Otherwise, it is impossible. Yes or not? Without D2, you cannot able to achieve the output. Okay. Without D1, you cannot able to achieve the output. Yes or not? Input is passed from ear to ear like this. Okay. Okay. So fine. Now you understand your, so we created a system. So what we have to do with the system? Okay, what we have to do with the system? We have to identify, what we have to identify? We have to identify the reliability, reliability, reliability of the design system, design system. This is what we have to identify. Chetan, got it? Chetan, Aish, got it? Hello.
Yes, got it, sir.
Yeah. So we are creating one system. For that system, there are many devices are there. In those devices, every device will going to have the reliability, some percentage of what is that performance it will going to give. Reliability of 70%, this will going to be 30%, 20%, like that. But even though system is not completely giving 100%, okay, but I wanted to achieve the 100%, how we will going to do? That is the problem statement. Actually, that is just we discussed all these things. Okay, now take this one. So or this R1 is a reliability of the, okay, device. Again, R2 is also reliability of the device too. R3 is also here. R3, sorry, R3 is the reliability of the device D3. But still, I cannot able to achieve the reliability 100%. Why? The reason is why? Tell me why? Why? What is the reason? What is the reason, Aish? Not got it. Okay, see here. Now everybody observe here. Suppose think like that. Suppose assume. Please assume here. Assume here. Okay, assume here. Assume. Assume here. Suppose we will going to have a devices, two devices, you take it. Okay. I have a system here, something like I have a system here, something like this. Okay. Here D1 I will going to connect. Again D2 I will going to connect two devices. One device here, another device here. Okay. Like this I will going to connect. This is input. This is output. Okay, na? Fine. Now observe here. Consider. Now this is take it as reliability is R1. This is reliability is R2. Consider if D1 is giving 90% of reliability. Understand? 90% of reliability. Okay, understand that one. Okay, 90% of reliability it is giving. Again, one more. This is a complete system. Yes, sir. Again, this one also D2 is also giving 90% of reliability. Yes or not? Then what is the total reliability of the system? Now you people tell me. So this one also giving 90%. D1 is also giving 90%. D2 is also giving 90%. Then what is the total reliability of the system? Just say, what is the total reliability of the system? See, reliability, total reliability of the system, reliability of the system is equal to, there is a formula, R1 into R2. So what is R1? Actually 90%. What is R2? 90%. So nothing but 0.9. You take it as 0.9 into again 0.9. What you will going to get it? Tell me. What you will going to get it? 0.81. Yes or not? Nothing but what? The complete system. Yes. Still it is giving 81%, not 100%. Yes or not? Yes or not, guys?
Yes, sir.
Okay. See, we got 90%, 90%. That is, I will going to consider this one as a 0.9. Okay. 0.9, 0.9, I will going to consider. Then still, when you multiply this one, 9 into 9, 9 into 9, you will going to get 81.81, nothing but 81%, totally 81%. Still, we are not able to achieve the 100%. Yes or not? Why? So that is the reason why. So again, how to increase this reliability? Okay, how to increase the reliability? That is the question here. That is the query. That is the problem statement here. Still, we are getting 90 for device 1, again 90 for device 2. But even though I am not able to achieve the 100%, so how to make that 100% reliability for this particular system? Yes. Understood?
Yes, sir.
Okay. Now, so what we have to do for this? Suppose think like that. For this one, there is a technique. So that is the reason why we will going to apply the algorithm. Reliable design algorithms we will going to apply. See, I am giving 90% here. This device is giving 90%. Like this, one more copy I will going to add here. One more copy I will going to add here. 90 D1. Okay. If I give the input here, if this is not working, this will going to work. If this is not working, this will going to work. Automatically, I can able to increase the reliability percentage here. So that is what exactly we have to do in this particular reliability design. Okay, we will see further about that. Okay. So there is some statements I will going to write here. What is that statement? Is nothing but here required to improve the reliability of required to improve the reliability of system. Okay. And how many devices are required? Number of devices required. Number of devices required for the system to increase the reliability. So these are the things you have to understand here. Okay. Actually, this whatever the things I said, just I given the problem statement. That's it, nothing else. Okay. So let's go to the next one. We will understand what is that exactly. Okay. Now take Chetan. Okay. So see these things. I'm going slow here. I will make it a little bit faster. Okay, see here. Everybody observe here. Now what I will do, how to improve the reliability? That is what the question is. How to improve the reliability. Okay, now see here everyone. So this is the system. Take this is the system. Okay. So here I will going to connect the devices. This one consider R1. Again here I will going to have the devices. Here consider reliability is R2. Okay. Getting everyone? Okay. Now see here what we will going to do. Please observe here what we will going to do here. Hence before, how many devices I connected? Only one. But here I will going to connect D1 as well as D2. Okay. Here, sorry. Okay. Again here also same. Sorry. Wait. Here also D1. Two D1 devices I will going to connect. Here I will going to connect D2 device. Clear everyone? Now what happens automatically if D1 is not working, automatically another D1 will going to work. Yes or not? If one D1 is not working, other the same device, same copy of the device, it will going to work once again. Okay. If that fails, this will going to work. If this fails, that will going to work like that. Then automatically we can able to increase the percentage, right? Reliability percentage we can able to increase, right? Okay. Now I will going to say, see here for this one, I will going to say the stage 1. For this one, I will going to say stage 2. Okay. So how many devices you are using? Basically here we are using, basically if you go back, how many devices we were using? Basically only one device we are using. If you want it, how many devices, if you want it, you can able to use it. If you want it, you use 3 also, no problem. D1, D2, D3 like that. Same copy, D1 copy, you can able to use the 3 devices. If you want to achieve 100% here also, you can able to increase. D2, something like 3 devices, you can able to increase here, no problem. But what exactly I want it is 100% achievement I have to increase. Okay, reliability percentage I have to increase. That is what exactly. Okay, now see here, I think you people got the stage. Okay, this is stage 1, stage 2. Stage 1, how many devices you will going to add, that is matters. Again, stage 2, how many devices you will going to add, that is matters. Because the reason is, how many devices if you add in stage 2 to get the 100%. Again, how many devices you will going to add in stage 2 to get the 100%. This is what exactly you have to understand. Okay, now see here, for example, everybody, for example, understand here. See, this one is giving 90%. See here, observe here. Everybody observe here. This one is completely, if you add these two, what is that? Suppose think like, assume like this. This is giving 99.9%. Okay, 99%. Okay, 99.9% it is giving into this one. Basically, we know that 90% it is giving. So if it is connected 10, if you connect one device, it will going to give 90%. If you connect two devices, it will going to give you 99.9%. Then what will go? 99.9 into 90% you do. Okay, it will going to increase or not? It will going to increase or not? That is what exactly we are talking here. Okay, so nothing but to increase the reliability of a system. To increase the reliability of a system, in stage 1, how many devices you have to connect? Again, in stage 2, how many devices you have to connect? That is what you have to identify. Okay, that is what you have to identify. Now, so see the formula here. How to calculate the here I will write how to calculate the reliability of system. Okay, so this is the formula I will go to write. Please observe here. Reliability of system S1. Okay, reliability of system S1, nothing but stage 1. Okay, what is that? 1 minus, please observe here everybody. 1 minus, again 1 minus Ri, nothing but reliability. Okay, so power M, nothing but copy of the device using whatever the copy you will going to use here. Copy of the device. Understood? This is the formula. 1 minus Ri whole power M. Okay, this is the how many copies you are using. Here you are using how many copies? 2 copies. Yes or not? 2 copies, like that. You have to write it. Now see here, everybody observe here. Okay, everybody observe here. For this one, 1 minus. If it is 1 devices, what happens here? 1 minus. Okay, 0.9. So if it is 1 devices, I will going to make it 1. But here, how many devices I connected? See here, how many devices I connected? Observe here, how many devices I connected? 2 devices. Yes or not? 2 devices I connected. So that is the reason why M is equal to 2 ovals. Okay, done? Everybody done? So what you will going to get it? Basically 1 minus 0.01 you will going to get it. Nothing but totally you will going to get 99.9%. So that is what I said here. Okay, if you connect 2 devices, that's why in the system, if you connect 2 devices parallelly, so how I am connecting here devices parallelly. Hence before, how I am connecting, I was connecting serially I was connecting. But here it is not like that. D1 is there, another one D2 is there. See, I will going to give like this. Okay, the connection will be like this. You will going to give the input here. Okay, input you will going to give it. It will move like this. Okay, if this is not working, surely it will work this one. If this is not working, surely it will work this one. Yes or not? That is the beauty of connecting parallelly. Okay, if you connect the device parallelly, automatically you can able to increase the performance and you can able to reduce the failure. Yes or not? You can reduce the failures. So that is what the reason is, we will going to connect the device parallelly. Here what we are doing, we are connecting parallel. Please understand. Here also, if any additional device is there, we will connect parallelly. Okay, so if extra devices if you add, then this is the formula you have to play. Okay, this is the formula you have to play. Okay, so that is the reason why, see, connect the devices parallelly. Okay, connect the devices parallelly. It says that very clearly how much percentage you are getting. That is the reason why I calculated this one. Okay, so for two, if you connect two devices, you are getting 99.9%. But see here, for serially, when you connect serially, that's what I told you, D1 D2 I connected serially, right? So that time this one 90%, this one is 90%. 9 into 9 18, yes or not? Sorry, 81, yes or not? Okay, nothing but 0.81%, nothing but 81% it is giving. But here, see here, but here 99.9 into, okay, 90, do 99.9 into 90. Then you will going to increase the percentage, right? Yes or not? Still you will going to increase the percentage, right? So that is what exactly we have to understand. How many devices if you connect to the particular stage, then you can able to increase the reliability. That is what. So how long the marker will going to work? Okay, we have to understand. Okay, so that is the reason why if you go to the any particular company and all, so they will going to keep one marker. Okay, for suppose if that marker is not working, they will going to have another marker. If it is not working, they will use another marker. That is what exactly. That is what. So that is the reason why I will going to connect the devices parallelly. If D1 is not working, another D1 will going to work. Getting? If D1 is not working, another D1 will going to work. Okay, that is the reason. Okay, fine. I think you people got this. Now, wait. Chetan got it, Chetan? Chetan understood. Hello.
Yes, sir.
Aisha.
Yes.
Aishpa.
Yeah,
Aish.
sir, yeah.
Aish Ilva. Aish, you got it, Aish? Okay. Okay, pa. Okay, okay. No problem. So that's why. So you may ask me, sir, how we got 99? This is the reason we got 99 here. Two devices. That's why M is equal to 2. Okay. RI value I taken. That is what where I taken. That is already 90%. I said, right? So that is what I taken. So RI value is 90%, nothing but 0.9. Okay. When you calculate this one, 1 minus 0.01, you will going to get the 99.9%. That's it. So this is reliable is improved. So there 90%, if you connect two devices for this particular stage, reliable is improved. Okay. Again, one more thing. So that is fine, no problem. This is fine. Connect many devices and you can able to increase the reliability. But what about cost? Who will going to give the cost? Okay, cost matters, right? Okay, suppose think like that. If you want to increase the 100% reliability, so what you will do? You will going to connect 10 devices, it will become 100%. But for think like that, each device cost is 50 rupees, but your budget itself 200 rupees. Okay, your budget itself 200 rupees. Then what you will do? It is above the cost. It is crossing the whatever the cost you have. Okay, basically you fix the cost is 200 rupees, but it is going for somewhere else. Then automatically you will going to face the loss. Yes or not? Automatically you will going to face the loss. That is also important here. Again, nothing but first we are discussing about reliability. Now we are discussing about what is that cost. Cost and reliability. See, basically I will tell you very simple. What it says that exactly, I will tell you what is it says that if you want to design any system, please observe here, if you want to design any system, they will going to say very clearly, you create a system with zero cost, again with the 100% reliability. You people tell me, if it is like this means this is really super. See, create a system. Okay, create a system which is consuming zero cost and giving 100% reliability. If this is happening, okay, it is a great company. Okay, if this is happening, really that is a great company. Okay, software companies, all those people, they will going to think like this only. That is what we call it as reliability design. How much devices are required to maintain the 100% reliability, and they have to reduce the cost with less number of costs. They wanted to achieve more. Everywhere they will going to see this one only. Okay, understood? I think you people got this. Okay. Now we will going to see how this algorithm. Okay, we will going to see how this algorithm. Okay, here we will going to see how this algorithm will going to work for this. Okay, how this algorithm will going to work for this. So we will going to apply the algorithm. So for that we need a formula, right? We will going to show that formula. We will going to discuss that also. Algorithm. Yeah. Algorithm helps to design to increase the reliability. Okay, now fine, done. So what is the formula here? So we will going to apply the algorithm. See here, everyone. Okay. So algorithm, I will going to write the algorithm. So what is that algorithm? So consider device D1. Consider device D2. Okay, D2. Consider device D3. Okay. So you take two devices is enough. Okay, D1, D2, you take it. Again, cost is C1. Again, here cost is C2. Again, reliability is R1. Again, reliability is R2 here. Okay, fine. Everything is fine. Now, what I will going to do? I will going to apply a formula. So how much devices we can able to add to that particular system so that we can able to achieve the 100% reliability. That is what we have to identify. Now, number of devices. Okay, at the stage. Think like that. This stage, how many devices we added? Tell me, this stage, how many devices we added? 2 devices I added. So that is the reason why I am getting 99.9%. But hence before, how much we are getting? 90.90%. But when I add the device, automatically you are getting 99.9%. But if you add one more device you added, you will get more. Yes or not? But cost increases. Yes or not? But cost will going to be increased. So that is the problem here. Okay. Here for that, what I will going to do? Maximum cost needed to spend to design reliable system. Okay, understood? So maximum cost, suppose think like that, they will going to provide some to design one system, they will going to say that fixed cost, they will going to say cost of the system. Think like that, cost of the system. So what is that? So I will going to use the notation that is called it as C. Here. Okay, suppose think like that, I wanted to buy the device 1, device 2, again all these things. Okay, to bring the device 1, this is the cost I will pay. To bring the device 2, this is the cost I will going to pay. Yes or not? Like that, they will going to fix some cost. Within that cost, you have to bring. Okay, within that cost, you have to bring the devices. So that is the reason why there is a formula. Please understand, there is a formula. Okay, what is that formula? Is nothing but to add number of device to particular stage as well as understand the cost. Okay, so first thing what I will going to do, number of okay, devices, number of devices at a stage, otherwise you take like how many number of devices at a stage, stage 1, nothing but stage 1 required, stage 2 required, all those things. Okay, so that is equal to take this one, cost C, this one cost C plus CI, this is the maximum cost they have given, right? This is the cost, so this is fixed cost. Again device cost, that is CI. Okay, device cost is CI, that is equal to sum of, see here, that is equal to, okay, sorry, minus sum of, please observe, summation, sum of I is equal to 1 to n, from 1 device to n devices. How many devices you are buying? That is device of the cost. Divide by, see here, divide by CI, cost of the device. This one I will going to take it as, what is that? Lower. Okay, floor value I will take it. This is floor value. Understood everyone? Everyone understood? Up to here everybody understood? Up to here, everybody understood? Ayush understood? Chetan understood? Up to here.
Yes, correct.
Got it up to here? Yeah. Very
Yes, sir.
simple. I will brief out once again. So we have to create a system. We have to create a system. So devices, I will going to add 2 devices serially. If you add these 2 devices, some amount of reliability it is giving, but I am not satisfied here. So that what I will going to do, parallelly I will going to connect the devices. Parallelly I will going to connect the devices so that I can able to increase the stage 1. Okay, stage 1% of the reliability again into this one. Okay, exactly, we will going to increase the percentage, right? Reliability percentage we will going to increase. So that is the reason why what we have to understand within this cost. Okay, within this cost, okay, how many devices you can able to buy and how many devices you can able to connect in these stages, stage 1, stage 2, stage 3, like that. So that is the problem statement. Whatever the things we have discussed, everything is related to problem statement. We will going to solve one problem, we will going to finish this one. Okay, okay, fine. Please rejoin once again.